think let's start. So yeah, welcome once again to all of you. We are now at the TinyML SG meet and greet. So I'm Vincent. I'm from the UBTECH Robotics, and we have Soham, which is from Sleek Tech, and we have Archana from DHL Express. Yeah. Okay. So moving on. So I would like to take this opportunity also to thank all the TinyML Talk strategy partner. So we have Aeon Device, ARM, Deep Light, Edge Impulse, ESMA Visual Sense, Phota Hub, Green Wave Technologies, Gravity Inc., HOTG, ImageMod, Itemis, Pika Tech, Latent AI, Messing Integrated, Micro AI, NXP, Professors, Qualcomm, QZO, Reality AI, Renaissance, Redzen, SAP, Six Studio, SensiML, Sony Semiconductor Solution Corporation, ST Microelectronics, Stream Analyst, SingSense, and Synthia. So with all their partnership, made this TinyML Talk possible. Thanks to the strategic partner. I would like to also share about the upcoming TinyML Summit. So this will be an in-person event on March 28th to 30th. And also there's this TinyML Research Symposium on March 28th. Yeah. So you can refer to the link, which is on the TinyML official website for more information. So for the next TinyML Trailblazer series, they will be featuring the success story with Eric Pan, which is the founder of Six Studio and Chaiwo Makerspace. So it will be like 2 weeks from now on April 6th at 8 a.m. PST. And also, if you are here today, I welcome you to join the growing TinyML communities. As you can see, the community is really growing right now. 8.5K members in 43 groups in 34 countries. So we are one of the country as well. This is from Singapore. And also you can join us in the TinyML community on LinkedIn group. Okay, there's so far about 2.7K members and 5.4K followers. Okay, so join the group, network with the like-minded folks, and you'll make something great together. And also for you can subscribe to the TinyML YouTube channel for updates and notification. So for example, for the videos today, it will be posted to the YouTube channel so that you can rewatch it later on. Yeah. There's some other interesting talk that's happening around the world, so you can have a look as well. For the next TinyML talks, it will be featuring this very interesting project, which is how a middle school girl solved a real-life challenge using TinyML, which is used for gas leak detection, right? Yeah. So it's on March 25th, which is next Friday. So you can sign up for this next TinyML talk. So I would like to introduce myself. So I'm Vincent. So my focus is really on the AI, robotics, and also Internet of Things, machine learning, cloud and edge computing, and hence all these things are linked together with this TinyML as well, right? Yeah. So I'm also part of some of the community building, right? Yeah, and currently I'm also running some of the community as well. That's for the embedded system professional. Yeah, we'll share more on that later. So one of my favorite tagline is that get inspired and make things happen. Yeah, hopefully we are all this thought will be inspired and make something great together. And right now, yeah, I will let Miss Archana to introduce.
Yeah, sure. Thank you so much, Vincent. And yeah, welcome everyone. And I hope you have a great time here today. We are hoping the session will be much more interactive and have people also, talking with us today. So yeah, thank you so much for joining. I'm Archana. I'm currently working as a data scientist. But apart from that, in like the TinyML space, I sort of have like a very, inclined interest towards it. And to that effect, we have also started the Scale Down initiative currently running in Singapore. So I would love to tell you all about it. It's like an open source initiative that I and Soham started. So we'll also touch base on that later on. And yeah, after work, I also help out at a nonprofit called Women Who Code, which sort of helps to increase the representation of women in tech. And I help them by building analytical dashboards and helping them understand data better. So yeah, that's it about me. And Soham, do you want to go next?
Yeah, sure. Thank you. So hi, my name is Soham. I work as a machine learning engineer at a fintech startup in Singapore called Sleek. So as a part of Sleek, I build these really large models and deploy them to large servers and cloud GPUs and stuff. But then my passion and my passion and the stuff that I really like doing is actually taking those large models, optimizing them, and shrinking them down so that they can run on TinyML devices. So that's what I do in the evenings. And yeah, and just like Archana, I'm also helping out with Scale Down, where I'm developing an open source package to kind of help you optimize large models as well as deploy them to TinyML devices.
Okay, sounds interesting. Yeah, thanks for the introduction, Archana and Soham. Okay, so let's start to talk about how all this about TinyML, right? So actually, all this is they started off with all this Internet of Things. So probably you haven't you heard about Internet of Things, mostly. So yeah, and this is one of the reasons why TinyML is also a growing trend because of this Internet of Things. Yeah, so you can see this is all the global active connection for the IoT devices. So it's actually growing every year. And okay, so basically IoT devices will have the microcontroller and sensors and deploy it somewhere else, right? In the farm, in the agricultures, right? So they can collect and transfer data. So they can perform simple tasks. So microcontroller, so it's just like basic input and output. So it's simple tasks. And also they already have becoming very popular over the last few years. And there's more and more IoT devices out there as well. So nowadays, not just for the development, they also end products like smart home devices, fitness devices, right? And also used in the industrial setting. Yeah. However, all this is just 99% of IoT sensor data is discarded, right? So I guess sorry. Yeah, I guess all this is the IoT data are not potentially being used, fully utilizing. So how this Internet of Things and edge computing related? So most deep learning models are deployed on the cloud servers, and we wanted to run the models closer to where the data is being generated. So that's we call as edge computing. So we have the Internet of Things devices out there, but the cloud is somewhere far. So, but the sensors, the Internet of Things devices are the one that generating the data. So hence we wanted to make the inference, the classification at the device side. That's what we call as the edge computing. Okay, more about edge computing. So it increased in IoT device cost and increase in the cloud dependency. Because yeah, I will talk about more on the how this edge computing work together with the cloud computing. And also you need to have the edge devices that have their own data centers, which means they are able to process the data locally. And also, yeah, this computing is performed, where the computing is performed is called as the edge computing. And some of the applications such as security cameras and self-driving cars, right? So it makes sense that self-driving car we need edge computing because that's where the inferencing, we can't allow any latency to happen. Means like sending the data back to the cloud and then sending the data to the car, right? Then I think there's some time delay. Yeah. So what are some of the advantages of edge computing? Generally, it will reduce the latency. Okay, and reduce the internet bandwidth because you will be processed locally, and increase security because no data is sent out to the cloud, and also reduction in dependency on cloud services. So TinyML. So for me, the definition of this TinyML is actually another layer down. I mean, it's part of the edge computing, but it's actually a combination with the embedded system. Embedded system in this context, I mean, is those low power microcontroller with the constraint, right? So I think you see some of these devices like Arduino, and then the View Terminal, and then the Jetson Nano. All these are the microcontroller devices that is really low power, and also they probably not that powerful as a cloud, right? Or maybe some data centers. Yeah. So you can run the machine learning algorithm on the devices itself, means that they can able to know whether this is a cat or dog, right? Using the camera directly, not sending back the data to the cloud. And some of the popular machine learning algorithm like TensorFlow-like, and also this edge impulse is used on this platform. That's what I call it as the TinyML. So for cloud computing and edge computing, basically it's actually they can work together, so that it called as a hybrid cloud solution. So that you can train the things on the cloud and then deploy it at the edge, right? Because at the edge, the microcontroller might not be having the enough processing to make the training. Yeah, so that's why we need to have the cloud computing to process all the data, and then we deploy the algorithm, the model onto the edge devices. Yeah. So that's where this cloud computing and edge computing will work together. It's not independent. I mean, I think they are not independent. They will need to work together. Yeah. All right, so I will pass this to Soham to talk more about the TinyML in SG.
Yeah, thank you. Thanks a lot, Vincent, for introducing TinyML. So like I mentioned, like what Vincent was mentioning, right? TinyML is where we take models from and try to run it on the embedded devices itself. And people all over the world are working on it, both in the research as well as in the industry. And that's true in Singapore as well. So we wanted to highlight some of the communities, some of the researchers, as well as some of the companies who are working on it in SG. So we know of two communities, and I'm sure there's more, and if you have more, please feel free to share them in the chat. So there's the Embedded Systems Professionals Discord, which is actually being moderated by Vincent himself. We've also created a TinyML SG Slack, and you can join that at that link. In terms of researchers, so from NUS, Professor Tulika Mitra and Professor Ambuj are both researchers working on TinyML, and Professor Ambuj is a part of Wiser Lab. In NTU, so I've had the opportunity to work with Professor Shivam, and so Professor Shivam, he works on something which I find really interesting, which is the security of the ML model in the hardware itself. So security from like physical attacks, stuff like let's say cold boot attacks, which I find really interesting. There's also Professor Chang Chip Hong, who's also doing a lot of research on hardware security as well as optimization algorithms. In terms of industry, so Continental Automotive, they have a lab in NTU where they are working on TinyML. And there's also a few other companies like Dyson, as well as the company that Vincent works at, which is UBTECH. So with that, we also want to introduce like the team at the TinyML Foundation team here. So the team consists of me, Vincent, and Archana. We plan to do like paper reading events as well as study groups. And if you feel, if you feel like to participate, then you can also like, let's say, suggest events and be a speaker at that event as well. You can also help us organize events, and we would love to collaborate on any projects you're working on if you need help with, let's say, like coding or with hardware or whatever. and and we're also open to any other ideas that you may have. Yeah. Thank you. Vincent, maybe you want to take the rest.
Yeah. So for this right now, yeah, I have this exciting things. If let's say you are new on this TinyML, so the good news is that there's this Codecraft graphical programming for TinyML. Okay, so it's started off with a graphical programming, but actually it's powered up by H Impulse engine, right? So there's this platform called H Impulse. So Six Studio work with them to come up with something like just drag and drop, and then you can train the models and deploy the models, right? So you can try this out. I will share with you the links later. And then, yeah, so basically TinyML deployment process using the Codecraft is really simple, just 4 steps. I actually made some projects based on this as well that get me started onto this TinyML journey. So the step 1 is basically the model creation. So you can create the models like for motion recognition or maybe some voice recognition. Okay, so you have the model, and then after that you do the data acquisition where you collect all the data from the environment, and then after that you train it where you select the different configuration for the neural network, and finally you do the programming, which means you integrate with your hardware, right? So what kind of logic for that? So that's this just 4 steps. And then, so you can access to Codecraft right now from this link, id.tinkergen.com. So if you can see they actually using a real terminal hardware devices. So it's actually from Six Studio. So you can get that as well so that you can explore the possibility of the TinyML. Now, this real terminal is actually a very powerful devices that are able to do quite a lot of things, not just for TinyML, can also for some of the IoT project as well. So I have compiled these resources from some of my previous talk. So you can browse this as well. So some of the books, some of the websites, some of the courses that's available on the Coursera or maybe from the EDX, right? So that you can attend for free. Yeah. All right. So perhaps this I will pass it to Soham or Archana to talk about the scale down initiative. Yeah.
Thank you so much. Let me. Okay, I'll go ahead and present here, and then I'll share my screen if that's fine. Okay, so hi everyone. So we are starting this initiative called Scale Down, which is like a open source framework which helps neural network optimization. But Scale Down is so much more. So just to give you a little bit of background as to why we started. So last year we were doing this study group for TinyML. And what we realized is that a lot of people came up to us and they went like, oh, I really want to start with TinyML, but I don't have the hardware to start off. And, people came with varied backgrounds where maybe they have the hardware, but they don't have the software education. So we realized like TinyML on its own is a complex field involving a lot of different areas together. So I think that is what we are concentrating on. We are trying to figure out if we can give hardware to people, can they also help to make their own TinyML projects. So this is where the entire idea for Scale Down started. And so Scale Down out here, if you can see, we have this sort of cycle. So we believe we have like an education pillar, and we also have like a framework pillar. So framework is something that we are constantly developing, which is again like an open source package. It's also supposed to be like a Python package to support especially newcomers to quickly learn and quickly just plug and play it. And we also have the education part. And this is sort of being, added on by the hardware library. So that is what we will sort of provide, wherein like people can, this is an idea that we have that wherein people can literally use it like a library, where they can take in the hardware and then give it back once they are done using it. So this is like the entire idea. And I'll also share my screen to walk you over what it looks like on the website. I think okay, yeah, thank you so much, Vincent. Let me know if you can see my screen. And Soham, feel free to jump in case I missed out on something.
Yeah, we can see your screen.
Okay, thanks. So so this is what the website looks like. So we are continuously offering various optimization techniques like quantization, knowledge distillation, pruning. And we also offer ways to move between frameworks. We now realize TinyML has become good enough that it's being supported by various frameworks, right from TensorFlow to PyTorch to OpenVINO and to also like ONNXX. So that's used by NVIDIA especially. And and then NVIDIA Tensor RT2. So we are trying to make sure that there's conversion that happens of models between the frameworks too. So that is what the package on its own supports. And you can figure out how to get started by moving here. So it has like user guide and docs as well. And furthermore, we also have the library part, which is much more exciting. So currently it's only in Singapore, where we are trying to pull in the hardware that we have and trying to put it out to the community so that they can also use it and start building their own TinyML projects. We are hoping that people, once they start building their projects, they'll also sort of contribute back to the community and back to the knowledge base as such. So this is like our current set of hardwares present. So you can also go through that. And then you can request for new hardware. And this is what the cycle looks like. And again, it's only available in Singapore. So if you are based out of here, do take advantage of it. And and if you want to join us, since we are, again, completely open source and we are running it right out of our after work hours, you can join us and, feel free to fill up this form and let us know that you're interested and we'll reach out to you. So I think that is it, but I'll go back to the slides because I know a couple more slides we have on meet and greet. But let me know if you have any questions, and Soham, anything else that I missed out on?
No, I think that was awesome. Thank you.
Yeah, I think it's actually a really interesting project. Right? When I first met with Soham and Archana, when they shared with me this project, I think the community people will definitely love this, right? Because you have been putting in a lot of efforts on all this, right? With people can get the hardware and so on, right? Then to learn and to interact with people and then to network, right? And also this is not just limited to the hardware itself is limited to Singapore, as in we need to pass you the hardware, right? But I think the community that we are part in is actually the global community, right? So where your project might be features in the global TinyML talks and others, right? Yeah. So I think this is really exciting.
Yeah.
Thank you so much. So let me go on to the next slide because that's like the exciting part of today, right? So thank you so much everyone for joining in. So I do know we sort of titled it meet and greet and we really wanted it to be informal too. So you have to, this is like a webinar, so you'll have to raise up your hands to be unmuted, but we really encourage that. So whoever wants to go ahead and speak up, you can let us know your name, let us know where you sort of work, maybe study, maybe what is like the thing that interests you about TinyML, and lastly, one interesting fact about you. So, and so these are like a few questions and we can, sort of get chatting. I know we can't do it in like a offline format, so we're trying to imitate it a little bit.
Yeah, so I think I saw someone on the panelist already, right? So maybe you want to start?
Hi, Stu, and thank you so much for having this talk and introduction and just sharing what you guys are doing from the community perspective. It's really very interesting, very compelling, a lot to do to digest all in one go. My background is really from weather forecasting. From there, I actually went into doing AI. And we've been actually teaching AI to some universities locally, to Singapore, NUS, NTU, and also overseas as well, from some projects that we're doing. But it's always in the context of larger devices, of course, like GPUs and CPUs and so on, never really something as small as a constrained device. And so I was really amazed that you guys are talking about really doing ML on things like the Arduino, which has like 32 kilobytes of RAM and stuff like that, right? So that's really interesting and exciting. And I'm just wondering, what do you think really is the applications for TinyML on these really constrained microcontrollers? Do you see really any serious applications for those things?
Yeah, sure. So maybe I can, talk a bit about that. So a good way to think of places where TinyML might be applied is to see the places where TinyML kind of really shines, right? So places where you need low latency. So that could be, for instance, in an autonomous vehicle where you don't want to, let's say you're in a tunnel or something and you don't have an internet connection, and you don't want, or maybe you have a slow internet connection, right? And you don't want your you don't want your car to send a request to some cloud server and then it gets delayed by a second, and the car doesn't break fast enough. So that's one of the places where you might want to use TinyML. The other one is internet access. So there's a lot of places where you don't have access to internet, or not even internet, right? Like no cellular networks or any kind of networks really. So let's say like in a mine, or let's say in forest areas where you may want to track animals, right? Like set up camera traps, places like that. You may also want devices that are just running in the background for like a long period of time, and you may not, and they could be in remote areas where there's no way to power the device apart from like having like a battery. So let's say you want to track forest fires, or you want to track, like let's say you have a transmission line and you want to track if the transmission line is working properly or not, or maybe it's been damaged. So you could have like a long running, you could have like a small battery powered device with maybe a camera or something, that just runs without needing a lot of maintenance or a lot of power or something for a long time, So yeah, those are places where TinyML is like really important.
Yeah, perhaps I wanted to add on, which I was thinking just now, is some of the real application that really shine. I think is maybe in something like predictive maintenance and those are abnormally detection, right? So where factory, right, they can deploy these sensors just for the, let's say the motors or whatever, right? So they can just track that, before the motor breaks down, that they roughly know already that is going to break down, right? Then they help them to do the better preparation for all this, right? Yeah. So I have seen some of these cases. They really push the hardware limit to really can run all these things on the edge.
Thanks,
Yeah.
thanks, guys. I was wondering, because for a lot of the autonomous stuff that's happening right now, like you mentioned cars, for example, right? They usually use very sophisticated systems. I'm sure all of you have listened to that amazing Tesla video, right, where the guy talks about the internal representation of how they represent roads and collisions and other stuff. It's just amazing how they combine all the cameras. But they actually using very high powered, although it's embedded in the sense that it's autonomous, but it's actually very the amount of CPU power processing power it has is actually very high. I like really your example about predictive maintenance. A few years ago, I was involved in a project where it's got to do with solar panels. So when you talk about solar panels, the part that fails the most is really the power converters, where they convert from DC to AC. And within the converter itself, they've got tons of sensors, usually about 40 different sensors for all kinds of things, right? And actually, we were actually running a workshop on how to actually detect failure for those things. And it's really interesting. I think really but I'm still struggling really to see the really, is there any kind of like industry motivated use cases that you are seeing in this space? Or is it really right now still in the hobbyist kind of space that you're seeing usage? And I'd really like to know also more from Archana as well. It's a wonderful open source project that you're doing. What are the use cases that you're seeing it being used for, whether it's hobbyist or whether it could be industry and so on?
Yeah, I think you bring out really good points, and I was about to actually say solar energy systems as well, because the moment you said weather forecasting, as it's a lot of even solar forecasting, especially irradiance forecasting, takes in weather parameters into consideration. We take irradiation, we take velocity, like the wind velocity, and so on. So in terms of this is obviously, I think, a bit more academic or even like startup related. I've worked with companies, and I myself did my master's in MUS. So my thesis was on doing edge computing on solar panels, basically like predictive maintenance. So finding out like, solar irradiance forecasting, and also finding out if there's dirt on the panel, and if I can classify the types of dirt, because not every dirt covers the surface. And if it covers a large part of the surface, then you need to sort of have someone go and clean it. If you know about panels, people constantly go and brush it off. And so yeah, that is one type that exists. But I've actually previously worked with Continental. So we actually used devices like Jetson, so NVIDIA Jetson, on autonomous vehicles. So anything from detecting to even doing obviously much more sophisticated stuff was done via using edge computing. So one thing you have to realize is when things go out, especially for buying, or when you actually build it as products so that someone sells it, you don't deploy one single use case. You oftentimes have like a couple of use cases. It might be detection, it might be pose estimation. There's like a lot of layers on top of what you sell, right? And when that happens, you need to make sure your models are as optimized as possible. Because even if you take a Jetson, right, you still won't get that much memory and compute as compared to a GPU. So you have to make sure that you are sort of utilizing it to its best possible needs. And so that is where working with frameworks and all really helps. I think back then we were using faster RCNN. I'm not very sure. I guess TensorFlow Lite doesn't support faster RCNN yet, but I think some other frameworks were replaced for that. So yeah, there's a lot of work that is done. I can tell you that for sure.
Yeah, and to add to your point also, Arnal, I think edge computing, there's like a spectrum. You have like some really powerful devices like the ones you mentioned that's present in EVs. But then you also have like Arduinos and an Arduino Nano, which is like the size of like a finger or something. So yeah, there's like a spectrum of devices as well. And in terms of like actual use cases, so for instance, Wild Labs, I believe, have actually deployed camera traps with which uses TinyML to detect animals. I've also seen a project out of Africa that warns villagers if like wild elephants are nearby. And yeah, the forest fire thing is also something that's actually deployed in California, I believe. Yeah.
Yeah, I think you were working with a project with ST, right? They were using cameras for detecting wildlife in this. I don't know if it was wildlife, but they were using neuromorphic chips, right? Do you want to talk about that?
Right. Yeah. So I was like, when I was doing my master's in NTU, we were also looking at deploying neuromorphic, using neuromorphic cameras in forests to detect like movements. So movements could be like animals, or maybe even like people who are doing illegal stuff like poaching, or foresting, or like cutting down trees and stuff like that.
How do you solve the power problem for those kind of like very remote devices?
Yeah, so building like really efficient, like using really efficient hardware. So sensors, for instance, especially cameras, take a lot of power. So you have to use efficient sensors, as well as efficient hardware, really. You can't use like a nano, and because that consumes a lot of power, right? So that. And then another thing that people do is so it's not actually like the executing neural networks that take up a lot of power. It's actually logging and like communications, so writing to memory or like communicating to like a cell tower or via Bluetooth or whatever, that takes up a larger chunk of power. So you try to minimize that as well. And finally, you just make sure your device like is in like a it's not in a sleep state, but it's in a partial sleep state where it still keeps tracking like some kind of activity. So you may have like a smaller model that just that kind of just keeps running in the background, and then when that detects something, then it activates a larger model that does better detection. So for instance, in the animal detection case, you could have like a smaller model that just runs in the background, doesn't consume much power, and just keeps detecting like, hey, is there an animal or not? And only when that model says yes, then that's when you run like a larger model to predict like the kind of animal.
Thank you, Soham, and thank you, Archana.
Yeah, no worries. Thank you. Yeah, love to hear from other people in the call as well.
Thanks Arnold for kickstart the ball, right? To introducing. Yeah, finally, it's glad to interact with you guys. Yeah. So anyone wanted to be the next? Yeah, we really wanted to know more about you, and then like what you're interested on, right? So that we can see how best we can support everyone. Yeah, so you can just unmute yourself.
I just wanted to add that it's okay even if you don't know a lot about TinyML. We don't expect people to know it. It's again, like as I said, it's a field which sits in between a lot of other fields, and it's not still widely used. So it's fine if you're still starting out and you have some very basic questions for us. It's completely fine. We want to make sure that this meetup group is as interactive as possible, since we live in this very tiny island too. So I think we can have like more chances for communication as such. So yeah, we can for sure leverage that. Yeah. And yeah, just feel free to unmute yourself whenever you feel like it. I will go ahead to the next slide. So yeah, we just have a short link here. Can someone just add it to the chat?
Yep. Let me see.
Never mind. So yeah, we thought it's best to have like a Jamboard to just understand if you have any ideas for any new events. You can literally fill the Jamboard up with whatever you want. Doesn't have to be like something very specific as well, but we want to make sure that the meetup group sort of is able to host people you want, maybe any new speaker suggestions and any group activities that you want. I know like Singapore is still limited to 5 people, so we might not have a bigger group activity, but in case like you want any projects to be done hands-on, something of this sort, just feel free to mention that. So I think the easiest way to use a Jamboard is just use the same color, and then yeah, you can just add it here. That's it. So yeah, I think the link is there already. So yeah, feel free to start adding your ideas, and I will stop sharing so that you can add it in peace. Yeah, we can just take 2 to 3 minutes and add it, Vincent and Soham, and then we can move on.
Try to see how I can use this Jamboard. Okay, yeah, I got it. Okay. So encourage everyone just go in and then just some ideas. Hands-on project. Yeah. So I think this the scale down initiative will be really interesting to have all this possible. of course, at the same time, we hope to grow the community and then we can get more hardware from the companies, right? So as long as we can do some projects, right? Meet up for copy, yeah, 5 of us. Okay. Yeah, maybe meet up for copy and then bring in the hardware as well. That will be fun. Okay. I think this is very interesting. I saw one is a workshop to get us started, perhaps a simple project. Yeah, I think that's really interesting. So that's where yeah, you get to know that. So open source project to collaborate. Wow, Pete Warden at TinyML SG. That's wow. We need to work on that. Meet up to show project. Yeah, I think that's also. Yeah, keep it coming. The more the merrier. Hardware exchanges, yeah, which is the scale down initiative. Yeah, in fact, I think for myself also, I do have some of the hardware here and there. Yeah, it's just sitting on my cupboard. I don't really have much time sometimes, yeah, but I manage. Yeah.
I think Suraj raised his hand. Olga, can I allow him to speak? Or, yeah.
Yeah, I think can directly unmute and open the video.
Yep.
Hello. Hello, am I audible to you?
Yes. Hi, Suraj.
Yeah, hi, Archana. I'm sorry. I was in a hospital. There was a bit of work there. That's why I couldn't unmute at that time. So sorry for that. I was too late for this because I was stuck up somewhere. There was that only. So
Yeah.
but I wanted to attend this meeting. I had been looking for long for this. So like I had a personal sort of query. Can I raise it right now, or is there a specific time for that?
No, please go ahead. I mean, this is an open forum. Feel free to raise your query as such.
Oh, okay. Thanks a lot. So I was working on ESP32 and ESP32 and ESP8266, and I was trying to bring TinyML there, but like there are not much of resources, and the ones that are available, they as well are not of that much of quality. So I was trying to collaborate with someone who has some sort of experience with that. So I was looking out for this meetup maybe here if somebody can help me over that.
So you're using the Wi-Fi module, is it, with ESP32?
Yeah, that one only, Wi-Fi module only.
Okay. I think like Soham, I know you unmuted yourself.
Yeah, sorry to interrupt you, but yeah, so you can use TF Lite Micro actually. So I think they recently released support for ESP32. So Vincent also shared about Edge Impulse, I believe. You can use Edge Impulse as well. They have like a UI that you can use to create a model and like just build like a quick POC as well. And you can also deploy it to the device as well using Edge Impulse.
Okay. Okay, thanks for that information. And I had one more doubt, if it's allowed.
No, no,
Actually,
please feel free.
yeah, okay. Actually, there's one ESP32 device, ESP32 microcontroller based device only. It was I don't remember the name actually. It actually has, it's like ESP32 cam. It has a camera and it has a microphone as well. So I was looking out for vision projects. If someone has built vision based projects on ESP32, because right now what I find is those MPU 6050 gyroscope, those are being used for using TinyML. But vision based projects for ESP32 devices, like if somebody can point me towards that direction, it would be good.
Yeah, so
It
I think
has a
I share
camera.
about the ESP32 camera. So I think that is the one that I think might interest you to do some object detection. I think it's also using the Edge Impulse platform. Yeah.
Oh, okay. So can you share the source for that if that's possible? Maybe I missed that part, no?
Yeah. Do you are you able to access to the chat? I posted it on the chat already. Yeah.
Oh yeah, I got it. Thanks a lot. I got it.
Yeah, so this is I think quite a recent project as well. So I think probably 1 month ago, I saw the community they have this kind of project where they really push the edge inferencing on the ESP32 cam.
Okay. I'll look into it then. Yeah, thanks a lot.
Yep, no
Yeah,
problem.
thank you so much. Yeah. I think, Vincent, we can go ahead. I know a lot of people shared their ideas, but we can keep the Jamboard link open in case you want to add more stuff to it. We'll just make it visible as such, and you can keep adding more ideas to it. But thank you so much, everyone who contributed. Vincent, can we move along on the slides? What do you think?
Yeah. I will just move along. Give me a moment. Okay.
Sure.
Yeah. Okay. I think just some few more slides that I think we can end our this. Okay. All right. So there was a Jamboard. So yeah. So this one I think probably just now you already have the 5-question post and so that you can kind of give some feedbacks on this talk. Okay. So appreciate your all the feedbacks on how can we improve for our next session. Okay. And yeah, once again, I would like to thank all these TinyML Talk strategy partner that enables these talks. Yeah. Okay, so I will start with these executive strategy partners. So ARM, so where they have this ARM AI virtual tech talks. Edge Impulse, the leading Edge ML platform. So I guess during the meetup we mentioned a lot, so you should definitely check it out as well. And Qualcomm, advancing AI research to make efficient AI ubiquitous. And Cynthia, okay, so end-to-end deep learning solution for TinyML and Edge AI. Platinum strategy partners. Deep Light, yeah, so fastest video analytics solution on ARM CPU. Fika Tech, global IoT solution. Reality AI, so that add advanced sensing to your product with Edge AI or TinyML. Renaissance. And the goal strategy partners will be Forta Hub, Maxim Integrated, Latent AI, Adaptive AI for the Intelligent Edge, Micro AI, NSP, Six Studio, the IoT hardware enabler, SensiML, build smart IoT sensor devices from data, ST Microelectronic, SynSense, and here's our silver strategy partners. Thank you all. So once again, I would like to remind you that the next TinyML talk will be for this interesting topic, how a middle school girl solve a real-life challenge using TinyML. So gas leak detection. So if you are interested to learn about how all this TinyML be applied to a real life problem, a real life challenge, welcome to join the talk. So just on final notice is for the copyright notice. So this is this multimedia file is copyright by TinyML Foundation. Yeah. So, and also this video will be uploaded to our YouTube video, the channel. Okay. Okay, with that, I think that's all for today. So anyone have any last thing?
Just want to say thank you so much, everyone, for joining in today, taking out your time. I know it's like a busy Wednesday evening, so thank you, everyone, for taking out the time today just to attend. And, you know, hopefully Singapore opens up more and we can have in-person events and talk to each other about TinyML too. But until then, do stay tuned. We'll have more talks and events. And again, thank you so much for joining in.
Thank you so much.
Okay, thank you so much, everyone. So we hope to see you again. So join our community and let's get inspired and make something great together. Okay.